That's a 3 in there. But we're supposed to use u equals 3x to help us evaluate this antiderivative. So I'm going to replace 3x with u. But what the heck do I do here? I've got dx. It's supposed to be with respect to x. If we're changing it to u, then we want it in terms of u. So take a derivative with respect to x of both sides of the substitution. And there, now we have something we can substitute to turn this into an integral with respect to u. We just need a 3. But you can't just throw a 3 in there, else it's not the same problem. You got to balance it out so that it would simplify to be back to the same problem. So I'm multiplying the outside by 1/3. So now I've got my du. I'm just going to put it in the back where it traditionally goes. There we go. Okay, now I'm ready to take my antiderivative with respect to u. I couldn't do it before I made that substitution. So an antiderivative, I'm trying to think of something whose derivative would be secant u tangent u. And who knows what that is? Oh, that's secant. Right? The derivative with respect to x of secant x is secant x tangent x. Okay? So the antiderivative of secant u tangent u is secant u plus some arbitrary constant c. And just when you finish these problems, this is pretty much done. We just want to put it back in terms of x. I'm going to put 3x back in place of u.